Hi everybody, welcome to Unit 4, Video 3. If you do not have your Unit 4 notes out, please take them out now. All right, so Roman numeral 4 here says, I can multiply and divide rational expressions. So it's asking us to simplify. So remember when you're multiplying or dividing fractions, it all needs to be in terms of multiplication. So in order to divide fractions, we multiply by the reciprocal. So what I'm going to do here first is I'm going to rewrite this in terms of all multiplication. So I'm going to leave this first fraction the same, 5y cubed over negative 7 times negative 14 over 25y. And then I'm going to turn this division sign into multiplication. And then I'm actually going to simplify this because this is special. Since all of this is to the 0, I know it's going to simplify to 1. So now at this point, I can cross reduce negative 7 and negative 14. Negative 7 can go into both of those. So when I simplify here, this is going to turn into a 1. When I simplify here, this is going to turn into a 2. The 5y cubed and the 25y can also be reduced. 5 goes into 25, so this is going to turn into a 1. Here I'm going to turn into a 5. And then y cubed over y to the first, these are also going to reduce. So this is going to leave us with y squared. So now all I have to do is multiply straight across. So when I multiply straight across here, I get y squared times 2, so that gives me 2y squared. In the denominator, I have 1 times 5, so that gives me 5. So then this is my answer, 2y squared over 5. Okay, with number 2, again, the same thing. You want to turn these division sign into multiplication. So we multiply by the reciprocal. So this first term here stays the same. So I have bq squared over c. Then I'm going to turn this into a multiplication sign. And I'm going to take the reciprocal. So this is c squared over q. Then here, again, I'm going to turn it into a multiplication, and I'm going to take the reciprocal. So this is bc over q. So at this point, you could cross simplify if you wanted, but I'm going to multiply straight across and then simplify. So I'm going to start with the b's. So b times b is going to give me b squared. Then I have c squared times c, which is going to give me c to the third. And then I have q squared by itself. All right, in the denominator, I have c all alone, and then I have q times q, which is q squared. So now I can go ahead and simplify. There's nothing to simplify the b squareds with, but this c to the third and this c to the first on the bottom, those can reduce. So I'm left with c squared on top, and q squared on the numerator and q squared in the denominator can simplify. So what I'm left with here, in the numerator, I just have b squared, c squared. So here's my answer. All right, so number 3. So what we're going to do here, again, same thing. We have to make these division into multiplication. But now the difference is here, I have all of these expressions. Remember, these are bounded by an invisible set of parentheses because they're connected by these operations. So what you want to do is you want to simplify if possible. So x squared minus 1, that can be factored. So I'm going to factor that into x plus 1, x minus 1. On the bottom, x plus 2, I can't do anything with that, so I'm just going to put it in parentheses, x plus 2. Here, I'm going to change the division sign into multiplication and then take the reciprocal. So I'm going to flip this into x minus 2 over x plus 1. On the last term, it's already in terms of multiplication, so I'm going to leave it where it is. I'm not going to flip it, but I am going to factor it. X squared minus 4 is a difference of squares, so that's going to factor into x minus 2, x plus 2. And on the bottom, I have x minus 1. Okay, so now that I've factored, or I've simplified everything I can go ahead and simplify top to bottom if possible. So here I have an x plus 1 in the numerator, I have an x plus 1 in the denominator, so I can go ahead and cancel those out. I have an x minus 1 in the numerator and an x minus 1 in the denominator, so those two can cancel out. I can't cancel anything with x minus 2, nor this x minus 2, but here, x plus 2, there's 1 in the numerator and 1 in the denominator, so those can cancel. So when I write my final answer, I have x minus 2 times x minus 2. So here is my simplified answer, because remember, you're multiplying these together. So x minus 2 times x minus 2. All right, with number 4, what we want to do first is we want to make these negative exponents positive. So to do that, we take the reciprocal. So I'm just going to flip them. So this becomes 2x minus 1 over 2x squared minus x minus 1 times, I'm going to bring down the multiplication sign, and then I'm going to take the reciprocal here to get rid of that negative 1 to make it a positive exponent. So I have x squared minus x over 4x squared minus 1. All right, so 2x minus 1, again, remember it's an expression. I can't simplify it, so I'm just going to put it in its parentheses. On the bottom, 2x squared minus x minus 1, that is factorable. So when I factor this, I have 2x and x, and the factors of 1 are 1 and 1, and I need them to add to a negative 1 in the middle. So that means it's going to be a negative here and a positive here, because this would get me a negative 2x. On the inside, I have a positive 1x, which would simplify to a negative x. On the right-hand side, in the numerator, the only thing they have in common is a GCF of x, so I'm going to factor that out. So when I do that, I'm left with x minus 1. In the denominator, this is a difference of squares, so that's going to factor into 2x minus 1 and 2x plus 1. Okay, so now that everything has been factored, I can go ahead and take a look and see if anything can reduce. Well, I have a 2x minus 1 on top, can cancel out with a 2x minus 1 on the bottom. This x minus 1 in the numerator can cancel out with this x minus 1 in the denominator, and that's the only thing that can cancel. So for my final answer, I'm left with x in the numerator over, so in the denominator, I have 2x plus 1 right here, and then times another 2x plus 1. So here's my answer. So x over 2x plus 1 times 2x plus 1. Okay, so I want you to go ahead and pause the video and try to do number 5. Okay, so let's go ahead and take a look at how you did. So in the numerator here, we had to factor out the a squared because that was the GCF. On the bottom, you had to say what are the factors of negative 3 that add to 2. So when we factored that, I got a plus 3 times a minus 1. On this right-hand side, I had to say, what are the factors of 1 that add to negative 2? So when I factored, I had a minus 1, and it's all over a cubed. So then, when I simplified, I was left with a minus 6, a minus 1 in the numerator. And in the denominator, I was left with a parentheses a plus 3. Okay, so let's go ahead and try number 6. So with number 6, what you need to do first is you want to move the order of what you have in the numerator here, because whatever is being squared, you always want it to come first. So that's going to look like this. You want to change this into negative x squared plus 1. All right, and then we have over 3x plus 4. So we want to make this division into multiplication. So we're going to turn it into multiplication, and we're going to take the reciprocal. So this is 9x squared plus 24x plus 16. And in the denominator, you have x squared plus x minus 2. All right, so now we need to simplify. So what we need to do here is whatever's being squared here can't be negative. So I need to factor out a negative 1. And when I do that, I'm left with x squared minus 1. On the denominator, I have 3x plus 4. And so I'm just going to put it in parentheses. On the right-hand side, this is a perfect square trinomial. So 9x squared plus 24x plus 16. If you did not know it was a perfect square trinomial, one of our special cases, then you'd have to do the x and do factor by grouping like we did last chapter. But if you memorize the patterns of perfect square trinomials, we know this is 3x plus 4, and this would be 3x plus 4. On the bottom, the factors of negative 2 that add to 1 are going to be x plus 2 times x minus 1. All right, so there's only one thing left to factor. And that one thing left to factor is up here, is this x squared minus 1. This is a difference of squares. So I can go ahead and change this into x plus 1, x minus 1. All right, so now that I've done that, I can go ahead and simplify what I can. So this 3x plus 4 and this 3x plus 4 can reduce. X minus 1 on top can cancel out with x minus 1 on the bottom. And that's all that can simplify. So for my final answer here, I'm left with negative 1, because that's what I factored out, And then I have parentheses x plus 1. And then in this term, I have the 3x plus 4 over, so in the denominator, I'm left with x plus 2. So then all of this here is my final answer. Okay, so number 7. Again, we want to go ahead and make sure we don't have any negative exponents and that we have everything in terms of multiplication. So I'm going to kind of do this to save space all at once. So here, when I factor it, I'm looking for the factors of 3 that add to 4. And the only difference between this one and the other ones is you have this y squared at the end. So we have to account for that y. So this is going to factor into x plus 3y times x plus y. Because the factors of 3 that add to 4 are 3 and 1. You could put a 1y here if you want, but the 1 is implied. So on the bottom, we're looking for the factors of 6 that add to 5. So that's going to give us x plus 3y and x plus 2y. Because that would multiply to 6, but it would add to 5. This middle one, it's multiplication, but I need to make this negative exponent positive. So I'm going to flip it. So it becomes 1 over x plus 2y. And remember, it's to a positive 1, but it's implied, so you don't have to put it there. And at this point here, I'm also going to flip this, and I'm going to factor at the same time. The bottom term here, the factors of 4 that add to 4, this is going to factor into x plus 2y times x plus 2y. And in the denominator, because remember I took the reciprocal here, I just have x plus y. All right, so now we can go ahead and see if anything can reduce. X plus 3y and x plus 3y can cancel out. X plus 1y here and x plus 1y can cancel out here. And then I have x plus 2y, x plus 2y. And here I have x plus 2y, x plus 2y. So the only thing I'm left with is 1. So that is my answer, 1. So all of that canceled out to just be 1. So everything on the top and everything on the bottom was the same, so 1. All right, so this next one here, what you want to do is you want to rewrite this kind of in the way you're used to seeing it. So I'm going to take this fraction here, x squared minus y squared divided by x plus y. And so they used this division bar here, but instead of the division bar, I'm going to use the division sign. And then I'm just going to write what I had, x to the 4th minus y to the 4th. All right, so now what I need to do, I know that this can factor, this is a difference of squares, but I'm not going to factor it. I'm going to wait because I think something's going to happen here. So I'm just going to rewrite this. So this is x squared minus y squared over x plus y. Then remember, I want this division to turn into multiplication. So I'm going to say times, and remember, we take the reciprocal. This is, there's a 1 underneath here, so this becomes 1 over x to the 4th minus y to the 4th. All right, so now I need to simplify x to the 4th minus y to the 4th. This is a difference of squares. So what I'm going to do is just rewrite this first term, x squared minus y squared over x plus y. And then here, it's going to factor out into x squared minus y squared and x squared plus y squared. So that's the reason I didn't simplify this even further, because I could already tell that it was going to be able to cancel out with something on the bottom. So I was just saving myself some time. You could have factored it completely. It just would have been an extra step. All right, so now this x squared minus y squared and the x squared minus y squared in the denominator, those can cancel out. That's it that can factor, or that can reduce. So on the top, I'm left with 1. And in the denominator, I have x plus y times, over here, x squared plus y squared. And that's it. That's your final answer there. Okay, so thank you for watching the video.